Good morning, almost afternoon, almost lunchtime. I think we're probably all excited for that by now. So I'm going to talk a little bit today about a whole bunch of things. I did have a big slide here talking about me and why I think I'm important, and somebody in one of my previews of this said, why do you have all that stuff there? Nobody really cares. Fair point. Highlight here, I've been in the industry doing stuff for a long time, sysadmin, engineer, DevOps, cloud, all kinds of cool stuff. Worked with some really great people. Learned a whole lot of stuff, did a whole lot of stuff. Some of it worked, some of it didn't. I'm going to share some of the stuff, especially over the last year and a half as Red Ventures has done kind of our heavy transition towards the cloud. Real quick shout out to my team. A bunch of these people are here today. Great bunch of guys. We've all worked really hard over the last few years to try and really bring the DevOps and cloud mentality into Red Ventures, and these guys have all been really helpful with a lot of things. What do I have to share? Well, I have a lot to share. So what you're kind of going to get over the next 25-ish minutes is this smorgasbord of stuff. I'm going to start with sleep, which strangely enough is really important to all of us, and we may not realize it. I'm going to talk a little bit about some comparisons to operations and what I like to call platform ops and kind of where I view our team right now. A little bit about AWS. A lot of this is slanted heavily towards AWS since that's kind of my home base right now. Monitoring, alerting, security, workflows, a whole bunch of stuff that some of which we've heard already today and some of which I'll add a little bit to. Sleep. So if you're in operations or in DevOps, it's highly likely that you work 24/7. It's highly likely that you work on a small team. It's highly likely that your small team is resource bound and you never have enough resources to get done what you want. And to be successful, I really hope you're getting enough sleep, because I know in a lot of situations, teams just don't get to do that. And it's really important for you to be successful at anything you do in life to get enough sleep. And I'm going to try and give you some hints today on some things that have really made it a lot easier to make sure that I get enough sleep at night and the rest of the people on my team get enough sleep at night. I'm going to touch a little bit here on kind of operations versus what I'm calling platform ops. So operations is kind of what I view as the old school way of we have a bunch of people in charge of a bunch of servers. They're out there kind of doing things really well. They have really great deep domain knowledge. They're creating what we've referred to a lot of times now as snowflakes, these one-off machines where this is kind of the mentality, and I used to be here where, oh man, this machine's been up 450 days. How awesome is that? And you try really hard not to reboot it because it's this really great, awesome thing. Not anymore. Platform ops kind of goes the other direction. It takes DevOps, which as we all know is you have to have a wide range of knowledge because it's likely you've done engineering and you're doing engineering, software engineering as part of your job, even if it's just building tools. But you also still have to deal with the kind of the system level stuff along the way. DevOps is also geared a little more towards turning things around really, really quickly, not always necessarily the best practices being followed along the way. Now, this is me, I'm biased. Your department, your group may not operate like this, but smaller companies, smaller teams, I think you see a lot more of this than you used to in the old operations days when people tried to be pretty standard. The other thing about platform ops and DevOps is we try and automate everything. Like if we have to do something more than twice, more than 3 times, we're trying to write a script to make it a lot easier, a lot simpler, a lot faster. So I was having some conversations about this the other night, and somebody pointed this out to me, is that the platform kind of takes what DevOps has been trying to do and abstracts it out. And the pivotal speaker, when he was up here, hit on this really well, in that you as an engineer should not need to worry about the platform. And to me, that's what the platform ops teams are doing for you. And if you're fortunate enough to be able to run Cloud Foundry, a lot of this is taken care of for you. Smaller companies, it's a lot harder to jump to a great product like that. Cost, time investment, all that sort of stuff make it difficult. So unfortunately, I think a bunch of smaller teams like ours end up building these platforms themselves, which, to his point, everybody does once. It's a good experience. Trying to do it too many times. Infrastructure. So I'm going to start with infrastructure here with continuing this comparison a little bit. So traditional operations, their main goal was a healthy infrastructure. They want to make sure these Linux machines are up and running and healthy and things are working. They're looking at their Linux data center or their Windows data center, make sure their data center is healthy. And then the apps just kind of get thrown out on top of that. And the operations teams, kind of hand that off at that point. They make sure the apps run, and that's it. And when we step into the platform world, we're actually more worried about healthy applications. So our goal is not so much to worry about, hey, are all these servers healthy? To be honest, I don't care if the servers are healthy. If they're not healthy, I'm just going to get rid of them and I'm going to roll in some new servers. It's cloud, that's what we can do. So I'm going to take advantage of that. AWS, Azure, Google, they all help us do that. These managed services that they provide mean that we no longer have to worry about, oh man, is my Redis cluster, is it going to be healthy? Am I going to have to worry about that? Who knows? If it fails, then AWS will just roll the master over to a different machine, and your software might blip a little bit. As long as you have your retries set up, everything will be happy. You'll reconnect, and you'll never even know. And so platform, to me, kind of extracts that underlying infrastructure concern out of what you have to worry about. Which brings me to what I think is kind of the most important thing that likely small teams, at least, aren't getting, and that we've heard a lot about already, and that's your monitoring and alerting. It's highly likely that if you're just getting started in this platform business, that you're taking this not serious enough, not even close to serious enough. This is the kind of stuff that is going to make sure that you know when something's going wrong and when something's going right. There's a lot of really important things here that you need to get right from the get-go. Don't bolt them on when you're done, when you've got applications out and running and you're like, oh, how do I know if this thing's healthy? You need to really start lower down and make sure that before you launch the application, you know at least how you can get some idea of what's going on. I think our keynote did a great job of telling you how difficult that is. Don't underestimate it. A couple of other key things with that is make sure that your alerts are going to the right people. There's nothing worse than getting a whole bunch of alerts that don't have anything to do with you and you just ignore, which leads to the last point here. Don't create alerts you're going to ignore. If you find yourself ignoring alerts, you're definitely doing it wrong. And I have a really, really great kind of story. Anybody who starts at Red Ventures as an engineer, guaranteed your first day, you will spend at least an hour trying to properly figure out how to filter out all of the old PHP errors that go to all of the developers that we have not taken the time to clean up. And these errors are our old alerting system. This is how we used to do it 10 years ago, even 5 years ago. We'd have all these apps. When there was an error, it would just get emailed out to all the developers to the tune of, we're down to about 1,200 a day. But I remember days when we would get 8,000, 10,000 emails a day, completely worthless. Nobody had any idea what was going on. They'd filter all of them to their deleted messages, and that's not really good alerting. It's not really helpful. So moving forward from that point with a little bit more on infrastructure, if you haven't really touched AWS and you're thinking about what you might want to do to get started, this is where you should start. So this is kind of a setup where you have two Amazon accounts. One's your staging environment, one's your production environment. It's a really great way to just say, hey, you know what? I want to do some stuff in AWS. Let's go and do this. Now, for comparison's sake, this is where Red Ventures is at. And actually, this slide is half of our infrastructure. So we have this many Amazon accounts with pretty much the same standard setup at each of them. Looks a little crazy, but part of what we're going to go through now is why I've done that and my team has done that and how it works for us. So some of the things that we built into this infrastructure, from the ground up, we built auto-scaling in. And we didn't do it because all of our apps have crazy scaling needs. We did it for a couple of other reasons, actually. Because with auto-scaling, what you're actually creating is an infrastructure that can heal itself. Auto-scaling forces you to stamp out your boxes in your cluster so that they're all the same. You have no snowflakes. You have this great environment where, hey, you know what? A machine is acting up. No SSH. Just kill it. If it comes back and that machine is acting up, I would kill that one too. If the third one comes back and you're still having problems, then you're going to need to bust out SSH. But there's no logging onto machines that are having problems and debugging them. You let auto-scaling heal that for you. Another thing you need to make sure you do while you're working through this, and I'll talk more about this shortly, is you need to build security in from the ground up. Don't go spin up a bunch of machines and think, are these secure? If you do that, I can guarantee you they're not secure, and you should really rethink your cloud approach because you're doing it wrong. Again, monitoring and alerting. Build it in from the beginning. It's really important. It's the only way you're going to know when things are wrong or when they're even right. So it's really important that you get started with that early. And probably most critical to our infrastructure is you need to make sure that you're building it in a standard, documented, and reproducible way. And I have some tips on how you can do that shortly. But the reason this is important is because you can't maintain this stuff with your skeleton crew if it's a whole bunch of random spider webs of stuff that nobody understands and nobody can figure out. So this is a really important part. Another thing I want to touch on here is the concept of immutable infrastructure. And I'm going to simplify it quite a bit from what probably the term really means to a lot of really, really smart people. I'm going to tell you what it means to me. Exactly what I just said. If you have debugging problems, kill the machine. Don't go in there and start editing and tweaking and playing around with stuff. Just get rid of it. Because if you have a machine that you're making changes to, you're creating snowflakes, and snowflakes are bad. Now, you're going to still have some snowflakes in your environment, but as a general rule, you really need to try and avoid them. And if you can avoid them, your infrastructure is going to be a lot easier to deal with. Another thing you get out of an immutable infrastructure, and this is something that Cloud Foundry is actually really awesome at from a container perspective, is you can roll things out whenever you want just to keep them secure. So if somebody were to get in your infrastructure and actually get on one of your boxes and install a rootkit, and it's in an auto-scaling group, just re-roll your whole auto-scaling group. And suddenly now your rootkit's gone. And you can do this daily. You can do this twice a day if you really want to. It might be a little bit extreme, but if you're in a really secure environment, go ahead and do this kind of stuff. This stuff is also super easy to implement in the cloud. VMware also helps you with it to an extent. Platform as a service really helps you with this stuff, so you can automate every single step of this. And to me, this is a big difference between kind of what DevOps automates and what Platform Ops automates. And that is the infrastructure itself underneath everything, the machines and all that stuff, is automated from the ground up. Salt, Chef, Puppet, this is completely my opinion. I don't use them. I rely on user data in my auto-scaling groups to set up and update and spin up my machines. I'm really afraid of a salt master sitting in one place that has control of my entire infrastructure across all of these accounts. I'm also really afraid of trying to manage individual salt masters in each account. Scares me. Ansible, still got to have super user SSH root access to every single box you're going to configure. I avoid that stuff as best I can. They're still great tools. Use them when you need them, but make sure you need them before you bring them in. Program and automate. Reproducible infrastructure. That's the key to really being able to take this sort of stuff and just stamp it out and move fast. It gives you some other advantages too, because if you're programming your infrastructure, it's just like your code. Teams can review changes before they're made. You can submit pull requests to make updates to infrastructure, auto-scaling groups, load balancers, security groups, all that sort of stuff. It's also easy to roll back. It's just like code. Kick it back to the previous version, apply it, and you're done. Another really great thing is you can share all of this stuff you're doing, share best practices and that sort of stuff. Segment.com, the Segment.io guys out in California, they actually have an entire Terraform stack to build out your AWS account with pretty much every service you're going to need. It's free. Just go out there and check it out. Learn some best practices, read some modules, get a good understanding, which brings me to how you program this stuff. Terraform is a really, really great tool for this. Plays nice with just about everything you're likely doing in your environment. Multiple cloud providers, VMware, OpenStack. The NS1 guys over here, they told me they have a CloudForm module, which is awesome. Grafana, Datadog, New Relic, all of your alerting and monitoring stuff, you can automate that stuff with Terraform. MySQL, Postgres, users, databases, automate it. Do all of it. Everything except your snowflakes. You're going to have them, whether you want them or not. They're going to exist. Cron boxes, utility boxes, that sort of stuff. Don't mess around with automating those. That's one place where if you really want to, you can try and use Salt and those sort of tools. Generally speaking, those machines end up being so random and so kind of special that you really just want to leave them alone. If they're in AWS, make sure you're snapshotting them regularly. That way, if it has problems, you can roll back to a snapshot and leave it at that. Really quickly, if you're in AWS, CloudFormation is an option, alternative to Terraform. This is just like the key couple of things. This slide had like 48 things on it when I first ran through this, and it made no sense whatsoever. So I really simplified this down to a couple of things. Terraform keeps track of your state, CloudFormation doesn't. So when you try and run a Terraform plan, if it sees things that it set up before that have changed, it's going to change them back. That way, if an engineer goes in and changes something in your account, Terraform is going to go ahead and make sure that gets switched back to what it should be. CloudFormation, a little gray around this, doesn't exactly work the same. So keep that in mind when you're considering the two. Terraform is relatively fast. Relatively meaning most changes will happen in less than a minute. Some take a little longer, like DNS, load balancers, that sort of stuff. But in general, it works really, really quick. Anybody who's used CloudFormation knows that it's not really, really quick. In fact, it's kind of really, really slow. If you ever wondered why JAWS serverless now takes so long to deploy your stuff, it's because under the hood it uses CloudFormation. Another big disadvantage to Terraform is that you have to have admin access to the account to really Terraform all of the things. Little bit tricky if you want to let your engineers actually run Terraform stuff. You can kind of work around this, but it's not particularly easy. AWS, though, if you're using CloudFormation, you can actually build templates, CloudFormation templates that are, let's say, a load balancer and a couple machines behind it in an auto-scaling group, and then you can throw that in the service catalog. You can give your engineers access to the service catalog, but not those individual services. They can click a button, CloudFormation will go out and build that stack for them, and they're ready to go. So that's a really cool advantage if you're only doing everything in AWS. Security. Remember, smorgasbord, jump around a lot. This whole slide, this was a couple of slides, and I combined it to this one, because in my career, a lot of times I underestimated how important SSO is. And SSO, for anybody who doesn't know, that's single sign-on. You have one place where all your users are. Do not underestimate how important this is as your organization grows. 5 developers, feels easy to just throw stuff out there and run with it. Don't do it, don't do it, don't do it, don't do it. Learn some LDAP, learn the basics. It's not that difficult. Your applications, a lot of times you can auth those directly against Active Directory or LDAP, or use something, there's all kinds of great tools, I'm blanking on them right now, that are out there that are hosted for you and will take care of this, and they're really inexpensive. If you have a bunch of EC2 instances running around, you can set up PAM and LDAP. It's a little bit icky still. I recommend a hosted service called Jump Cloud that is basically just hosted LDAP. They have a really great little agent. You run it on your machine, registers back with LDAP automatically. All your authentication goes through there, and you don't have to share SSH keys and that sort of stuff. People actually have their own accounts. Also, we'll go so far as to say, do not use tools that don't support SSO. GitHub.com, they don't support SSO, don't use it, even if it's just for that reason. Go for GitHub Enterprise, because that, even though you have to maintain the servers, supports SSO. You manage all your users in one place. Somebody leaves the company, you go shut them off in one place, and they're gone. A couple more things on security. I just touched on this, and I'll repeat it again. Do not share SSH keys, ever. When you create a new EC2 instance in Amazon, you attach a key to it. Do not take that key and hand it to your team and let them go access that machine. Set up individual keys. Or, better yet, in your user data, throw in the installation script for Jump Cloud and don't even put a key on that machine. Then it'll come up, it'll register with Jump Cloud, you attach the users you want, and you're all done. Piece of cake. Do not share your SSH keys. Another little gotcha that a lot of people don't catch when they're getting started. If you have 0000/0 on anything that's not an external load balancer, take a look at why that's there, because it probably shouldn't be there. It may feel okay now to give everything in your network access to your MySQL, your RDS instance, but as soon as you add a VPN connection or direct connect connection, anybody coming into your network through that connection now has access directly to your MySQL server, which is probably not what you wanted when you set it up. And you really got to think about this stuff at the very low level when you're getting started and expect that you're going to grow, because that's what we need to do to be successful, right? Next little jump around. Developer workflows. We're DevOps. We know automation is key. Don't forget that. It's really important to use standard tools to get this automation in place. I use Make all the time. Doesn't have anything to do with the fact that Make was created, what, for C back in the day? Like, Make is an awesome tool. Shell scripting, awesome tool. And you know what the great thing about it is? You're using Bamboo, you're using Jenkins, you're looking at all these other tools. If you standardize this stuff on Make files and shell scripts, you can jump between all of those very, very easily. You want to get started simple? Go to Circle CI, integrate it with GitHub, you're off and running. Although, be careful because neither support SSO. But you need a place to start to learn this stuff. Do that in your Circle file, your circle.yaml. Don't call individual special commands. Call make commands that anybody can run on their own machine, or you can run them in your CI/CD pipeline and test everything, and everything is great. Excuse me. Centralize. Start out with everything centralized. Don't create a bunch of deployment over in Circle for one thing, deployment in Jenkins for one thing, deployment in Bamboo for another. Centralize it all. Manage it all in one place. If you get to a point where you're having pain points from centralization, break it out. Don't overthink it. Hey, these people have a special need. That's okay. Take care of their special need. But start centralized. The real goal here is that we need to provide guardrails so that teams that have the expertise to go and do stuff on their own can do exactly that. They can run off and do exactly what they need within the guardrails that we have set up. And we need to document these guardrails and these workflows so that all of the teams around can take advantage of it and run with it as they need to, which is why documentation gets its own slide. README.md, not sure where that came from. It is one of the greatest things added to software development, in my opinion, in the last 5 years. Keep your project documentation with your project. Use this file. Very important, because it lets everybody know where to go for documentation. They pull up your code, bam, they now have all the documentation for your project. Infrastructure stuff, well, you're not really necessarily coding all of, well, you are coding that actually because you're using Terraform, right? But the documentation about like the big picture view of that, centralize all that, because then people know where they can go to figure out how to log into their AWS account and how to access certain things and that sort of stuff. Same with CI/CD. That's centralized. Centralize the documentation. Make this stuff mandatory in your governance. If you're a small company just getting started, create a governance doc and put one thing in it. Documentation is required. Really important. And on top of that, set a good example. I suck at documentation, and therefore my team sucks at documentation. It is actually the biggest thing on our to-do list for this year is to improve our documentation. We're all going to get it on our annual reviews that are coming up the next couple weeks, so you guys have fair warning now that you need to work on that. And the last thing I'm going to touch on, I think, is Docker. I went out looking for a great quote about Docker, and I hit these slides from a presentation. Jerome is, I think, still an active developer on Docker. At the very least, in 2014, he was a super active developer on Docker. The slide on the picture on the right is from his slides, and it basically is saying if you're using Docker, security is complicated. Even Docker says security is complicated. And it's really important to keep in mind the slide on the left. Docker containers are not VMs. Don't treat them like VMs. If you do that, you're making huge mistakes. A few super high-level things to keep in mind with Docker. Most Docker containers, when you jump into them, stuff's running as root. Don't do that. Add users. Run the applications as users inside of there. Stay away from root. Update often. Make sure that your base images get updated, preferably off of the automatic updating that Docker Hub provides when they get updated downstream. Alpine, Debian, all of those people, Ubuntu, they update their stuff regularly, and you can set these up to automatically rebuild your base images, and everything is good. For real security, try and run your file systems read-only. There's no reason, ideally, if you're getting started, do everything stateless in a container, and if you're doing everything stateless, there's nothing you need to write to the file system. So just shut that off. That way, if anything goes bad, if anybody gets into those containers, hacks into your application, they at least can't write to the file system. Makes a big difference. Start with small images. Alpine, great if you can make it work. There's a few gotchas. Debian, a little bit bigger, but just as good as giving you images that are small footprint, lots of things that aren't there to let you get hacked into and to make you have to worry about updating. Only use approved images. Don't let people build things for production off of any image they want on Docker Hub. Like, you need to know what's in those images. You need to make sure they're getting updated. You need to control them through a centralized repo. That way you can make sure they're getting updated. OpenSSL bug shows up constantly. There's a patch for OpenSSL. And every single one of your container images needs to be updated. So make sure that you're keeping on top of those stuff. And if you're running Windows containers, you're going to need to do all of this, and you're likely going to need to do it more often. Keep it simple. Kubernetes is awesome, really powerful. Don't start with Kubernetes. Start with something simple. We're playing around with Rancher right now. If you're in AWS, use ECS. Takes a little bit to get your head wrapped around how it works. It's going to be a heck of a lot easier to manage, especially when you're starting to push production workloads, if you're running on ECS. Drum roll. This is pretty much the end, so now I'm done. This is kind of what the important thing here is. Now, with what I'm calling platform operations, we can take DevOps to the next level where we can program and automate absolutely everything we're doing, including our infrastructure. And if you do this right, if you take advantage of all the tools that are out there, you're going to let your team get a good night's sleep every single night. You're not going to have alerts waking you up. You're not going to have things breaking. Your systems will auto-heal. All the technology is there. Build it into your apps. Here's some info on me. Like I said, not super important. My team's around. I suggest you ask them questions. Their answers are a lot more fun than mine. If you want to shoot anything at me now, though, you're more than welcome to. Silence. I wish I could say it's lunchtime, but that would be a lie.
No, you got one more.
One more? Yeah, we got one more. That's why I said it would be a lie. Thank you, everybody.